Welcome to O-Level Physics Online. In this video, I'll be talking about pressure. And by the end of this lesson, you will be able to define pressure and state its unit. Secondly, you will be able to explain some basic application of pressure in solid. And thirdly, you will be able to solve some applied and calculation question on pressure in solid. Our pressure can be viewed in three perspectives: in terms of solid, in terms of liquid, as well in terms of what? Gas. However, in this video, my attention is just going to be centered on pressure in solid. So before we move on, let's first look at this question. What would be more painful? Being stepped on by a 55 kilogram woman wearing stiletto heels, meaning wearing this, and being stepped upon or being trodden on by a 3-ton elephant. Which of two is going to cause more pain? The response using the knowledge of physics is going to be provided after the definition of pressure and the deduction we are going to make from it. Now, second question is this: why is it that sharp knife are better cut than what? Dull or blunt knife? The response will be provided after the definition of pressure and the deduction we are going to make from it as well. Now, what is pressure? Pressure is defined as a normal force per unit area that acts on a surface. Normal force per unit area that acts on a surface. Now, the first key term that we need to explain here is what is the meaning of normal force. Normal force is nothing than a pressure that is acting perpendicular to the surface. A force that is acting perpendicular to the surface is what we refer to as normal force. And the area occupied by that force is the area. Is what we refer to as what units are area. So in summary, we define pressure as what? Force per unit area. So just like what you're having, all the forces I'm having here are what? Are normal force. And the area they cover is what to refer to as what? Unit area. Now, pressure of magnitude P, when a force or thrust F acting on the surface area A, can be expressed mathematically as what? Pressure equals to F over A. Pressure equals to what? F over A. You know, it is known to us already that the unit of force is Newton. Unit of force is what? Is Newton. And the unit of area is meter square. Standard unit of area is what? Is meter square. So for us to get the unit of pressure like that, we are going to have it to be Newton divided by area, and that's going to be Newton divided by meter square, which will definitely give us Newton per meter square. Another unit that we can have for pressure is Pascal. And 1 Newton per meter square is the same thing as 1 Pascal. Meaning we can use the two units interchangeably. Either you use Pascal or you make use of 1 Newton per meter square. We have other units which will be discussed later while we talk about pressure that we have in liquid and a gas. Now, what deduction can we make from this formula? Pressure equals to force over area. Mathematically, if you look at this formula I'm having here, it implies that 1, pressure is directly proportional to the force if area is what? Is constant at constant area. Also, we can say that pressure is inversely proportional to the what? To the area, provided that force is constant. And we can just conclude from here that if pressure is directly proportional to the force, it shows that the higher the what? The force, the higher the area, the pressure is going to be. If the what? Pressure is directly proportional to the force, the higher the force, the higher the pressure is going to be. Likewise, if you consider the second case that I'm having here, the smaller the area, the higher the pressure is going to be. That shows that if you want to increase the pressure on something, of course, you can simply what? Reduce the what? The area that you have in that case. And that is the deduction we can make. And this one will enable us to answer the first question that I asked earlier on, that if you are being trodden or being stepped upon by a 55 kilogram woman, or you are being stepped upon by a 55 kilogram foot of an elephant, which of the two is going to cause more pain? Of course, it is clear that the area covered by the heel of stiletto is very, very small. And the area covered by what? By elephant foot is very, very big. And we have said already that pressure is inversely proportional to the area. That shows that the one that have smaller area is going to cause what? Greater pressure, meaning more pain. It will be more painful when being stepped upon by a stiletto heel than if you are being stepped upon by the what foot of elephant of mass 55 kilogram. And the second question that I asked earlier on, that why is it that a very sharp knife or a sharp knife cut better than that of what dull or blunt one? The simple response is just going to be because the area for the sharp knife is very, very small. As such, it's going to cause what? It's going to exert greater pressure. And the area for the blunt knife is very, very wide, very big. As such, it's going to exert very small pressure in that case. And those are the responses that we'll have regarding the two applied questions I asked at the beginning or introductory part of the lesson. Now, let's look at how we can make use of the formula for pressure to solve some question. The first question I'm having here is, calculate the pressure on a man's foot when a woman who weighs 520 Newton step on his foot with a heel which has an area of 0.001 meter square with all of our weight. Now, how do we solve this question? The first thing is for us to list out all the parameters given to us. They say a woman weighs what? 520 Newton. Remember, weight and what? Weight and force can be used interchangeably because two of them share the same unit. So we're given weight or force in the question to be equals to what? 520 Newton. And the area is given to us as 0.001 meter square, as you can see from the question. Now, we are required to calculate pressure. Pressure is unknown, as we have seen from the question as well. Calculate the pressure. Now, remember the formula for calculating pressure is force over area. Then substitute the parameters that we have there, meaning change the value of force here to what? To 520, and change the value of area here to what? To 0.001. If you change this one to what? 0.001, you are going to have the value of pressure now to be equivalent to 520,000 Newton per meter square. And that is all we have in this case. The second question we have is, the stylus of a phonograph record exact force of 7.7 times 10 raised to power minus 2 Newton on a groove radius 10 raised to power 5 meter. Compute the pressure exerted by the stylus on the groove. So how do we calculate this one? First, let us list out all the parameters given to us. Force is given to us in the question as 7.7 times 10 raised to power minus 2 Newton, and we're given area to be unknown. If you look at the question, we don't know the value of area. And what the radius is given to us as 10 raised to power minus 5 meter. Now, the next thing is that, no, we can't calculate pressure without knowing force. We've known already that pressure equals to force over area, right? Pressure equals to force over area. So that shows that before we can calculate pressure, we must know the value of force and area for solid. Now, in this case now, how do we get the value of the area? The first thing you have to look into is that the stylus of a phonograph is something circular. That shows that if you want to get the value of area of that stylus of phonograph is going to have the area of circle, which is given by pi r square. Then from this, we can just substitute the parameter. Pi has a value of 3.142 times 10 raised to power, or 3.142, then multiplied by the radius given to us in the question, which is 10 raised to power minus 5. Then square is based on the formula. We have 10 raised to power minus 5 square. Then from this one, we have the value of area now equals to 3.142 times 10 raised to power minus 10 meters square. Then, but we've known that pressure equals to force over area. Therefore, we can substitute a parameter into the calculation now. That shows that we're going to have area now to be equivalent to, the pressure now to be equivalent to 245066,836.41 Newton per meter square. The third question we have here is, how much does a woman weigh if the pressure she exerts while standing on one foot has an area of 0.6 meters square and exact pressure of what? 16 Pascal. We are calculating the weight of the woman, which is equivalent to force, don't forget. Now, let's list out all the parameters. Force is unknown from the question. And we have area is what? 0.6 meters square. Area equals to 0.6 meters square. And we have pressure is given to us as 16 Pascal. Remember, pressure equals to force over area. Then from this, you can substitute all the parameters. We have 16 equals to force divided by 0.6. Then from this, if you cross multiply here, you are going to have 1 times F, that will give us F. Then you have 16 times 0.6, like that. Then you are going to have the value of force now to be equal to 9.6 Newton, which shows that the weight of the woman is equivalent to force, and that will be equivalent to 9.6 Newton, like that. And that's what we are required to calculate. Then the fourth question we have here is, what is the area? This time around, we are required to find the value of area of a car that touches this road if the car's weight on the tire is 3,072 Newton and the pressure exerted is what? 48 Pascal. So from this one, let's list out all the parameters given to us. Force equals to 3,072 Newton. And we have area is given to us as what? Unknown. We don't know the value of area in this question. And we have the value of pressure is 48 Pascal. Now, remember that pressure is given by the formula force over area. Then substituting the parameters there, you are going to have pressure now to be equals to 48 equals to 3,072 divided by area. If you cross multiply in this place, you are going to have 48A equals to 3,072. Divide both sides by 48. Divide this side also by what? By 48. 48 and 48 will cancel each other. Then this one, 3,072 divided by 48 is going to give us the value to be equal to 64 meters square. And that is the answer to the first question that we'll have in this case. And the second to the last question we have is objective. A vehicle sink into soft ground. The vehicle is changed so that it does not sink as far. Which change is made? So in this question is a technical or applied question, which is part of our objective dimension area. One, a lower center of mass. Of course, this one is not going to be what, right? Which changes is made for the vehicle not to sink further, or for it not to sink far? What changes can somebody make in that case? If you lower the center of mass, of course, you are increasing the stability of the car. Because if you want to increase stability of a body, you can just lower the center of mass or center of gravity. And the more you reduce center of gravity, the more stable that thing is going to be. As such, it's going to make the car to sink further if it is stable. Then the second one, if you use powerful engine, remember the pressure exerted by the car on the ground is independent of the what of the engine. It depends on the area occupied by that what, by that car or by that vehicle. As such, this one is not going to be right. If you wheels that are what are further apart, if the wheels are further apart, in that case, you are just doing what? You are just increasing the pressure, because if they are further apart, you are distributing, you are spreading the what? The force exerted by that car on the ground. As such, it's going to narrow the what? The area and make the car to sink further. And the last one we have is what? Using wider tire. This one is going to be the correct answer, because remember we said pressure is inversely proportional to the area. Pressure is what? Is inversely proportional to the area. If you increase the what? The area of the tire, meaning if you make the tire to be what? To be wider, automatically you are reducing the what? The pressure exerted by that car on the what? On the ground. As such, D is going to be our correct answer. And the last question that we'll have here is, a man is in contact with the floor. In which of these situations does he produce the least pressure on the floor? In which of these situations does he produce what? Least pressure on the floor? Now, for us to answer this question, we still go back to our formula. Pressure is what? Force over area, which shows that pressure is inversely proportional to the area, or pressure is directly proportional to the force. But if you look at all the options I'm having here, kneeling is independent of force. Lying flat on his back, independent of force. Standing on the both feet is the same person. Standing on one foot is still the same person. So meaning the force is constant. The weight of the person we have is constant, the same. Now let's look at the area. If the person is kneeling, and if the person is what? If the person is lying on his back, or if the person is standing on both feet, or if the person is standing on one foot, for the person to what? To exert least pressure, automatically he must exert maximum what? Area. He must occupy maximum area or more, or very wide area. And out of the four conditions I'm having here, the only one that the person is going to occupy more area is going to be that of B, because lying flat on his back is going to cover more space and take more area compared to any other one. As such, option B is going to be the correct answer. Because, in summary again, because the more the area, the smaller the pressure exert on the floor or on the surface is going to be. And that's going to be our answer to the last question we have here. Thank you for listening. So don't forget to subscribe and click on the notification button in case, so that any video I'm uploading you will be able to be alerted on that case. And don't forget to put any question you have in the comment section. And if you want to support this video also, you